Wait for it. What's up? Welcome back. In this episode, you'll see how to solve day 6 for the Advent of Code challenge in 2023. This one's called Wait for It. And in this scenario, we have some races, some boat races. And the idea is that we have some data from a boat race here, and the document is going to describe how long the race lasts and the record distance for the race. And our job is to figure out what we need to do with this toy boat to make it win the race. And the way that the race is won is by holding down a button on the top of the boat for a certain number of seconds or milliseconds. And depending on how long we hold down the button, that will increase the speed of the boat. And then we let go of the button and the boat travels some millimeters, some distance. If we hold the button down for a really long time, it will go really fast, but it will only be able to travel a short distance if we hold it down for too long. In this case, what we need to do is break up this 7 to figure out if we hold it down for 1 second, how far will it go? Or 2 seconds, or 3 seconds, or 7 seconds. If we hold it down for 7 seconds, it doesn't have any time to travel anywhere. If we don't hold the button down at all, it doesn't have any speed to travel anywhere. So we need to find some middle ground where we're going to hold it down maybe for 3 or 4 seconds, and that should get us to travel 12 millimeters. So if we hold down the button for 3 milliseconds, then after 3 milliseconds, the boat will be traveling at 3 millimeters per second, and then we can let go, and then it will travel at 3 millimeters per second for 4 seconds, and it will end up traveling 12 millimeters. We've got some input here, and let's just play around with this and see if we can get this working. Okay, so we're going to drop this in here. Rather than using a here doc today, I thought it might be fun to talk about percent delimiters in Ruby. So we've already got the spaces between the words here. We can just change this D to match Ruby style, and we can say percent %W. Percent $W will give us the words as an array. So this is like another way of creating a list of words. So if we print out time here and we run ruby main.rb, then we get 7, 15, and 30. So that's like the words that are in this list separated by spaces. Now what we can do is just map this to I, map that to I, and we'll get back the numbers 7, 15, 30. So now we have an array of times and we have an array of distances. And what I've been excited to use is the zip method. So we can zip with distance, and this is going to give us back some new array that has subarrays where each element is the element from the arrays that were being zipped together. So we're combining all of the arrays, zippering them together. Yeah, zipper, I guess it's going this way. We're zippering the array elements together and we come up with this. So now we have a list of races where the first element is the time and the second element is the record distance. So now we've got some races, and what we want to do is iterate over those races. And for each race, we want the time and distance. And then we want to figure out like, what is I guess like we got to figure out what our answer is here. The answer that it's looking for in the first case is to count up the number of ways that you can beat the record. So if we look at holding down the button for 0 seconds, holding down the button for 1 second, holding down the button for 2 seconds, all the way up to 7 seconds, and then we want to see how far we can travel for each of those. So if we do time.times.do I, that will give us some number of seconds held or something, the number of seconds we're holding down. And if the number of seconds held, so distance in this case, so let's do this as like the record distance, and we'll call our new instant or our new variable distance is equal to the number of seconds held. That's going to be how long we've held it down. So that's our speed. And now we need to multiply our speed by the time minus the number of seconds held, right? It's like the time remaining. Seconds held times time minus seconds held. That should give us a distance, I think. So let's just print out time, seconds held, and distance. And here we go. So if we look at the first one, 7 and 0. Okay, so on the right-hand column here, we have 0, 6, 10, 12, 12, 6. And then over here, we have, as the answer for the distance traveled is 0, 6, 10, 12, 12, 6, 0. So this is like the far right column there is correct for distance. So what we want to find out now is if the distance was greater than the record distance, then we want to print out stuff, right? So if the distance was greater than the record, so in the first case here, we have 1, 2, 3, 4. This is an extra print at the bottom here. So we have 4 occurrences where the distance was bigger. Then we have a bunch more occurrences. Then we have a bunch more. So now what we want to do is the answer is the number of ways you can beat the record. So if we multiply these values together, you get 288, which is our answer for the first part. So we need to figure out a count. So if we do ways is 0, and then we'll do ways plus equals 1. Okay, so that'll be the number of ways that we can win. Actually, we can pull this out here, I think, right? Because we need the number of ways for the whole. No. Yeah, we need the number of ways for each race. P ways, right? We need the number of ways, and then we need to multiply these together. So we need to collect these up somehow and then multiply. So one way we could do this is we have some accumulator, and we'll start that at 1. And then we could say ACC times equals ways, and we'll print out ACC at the end and run this, and we get 288. So that is the answer for the example input. Now let's grab the real input. We'll grab our puzzle input here, which is similarly not bad. And we'll just paste this in, come over here, make that T, that D, and percent W dot map. Okay, if we run it against our example input, we get 44035 blah blah blah. For part 1, 4403592. Awesome. That was our answer. Okay. Now let's see what part 2 says. As the race is about to start, you realize the piece of paper with the race times and records is actually one race. So the kerning was wrong. So the kerning is like the space between the letters. And what this is saying is, oh, there's actually just like no spaces between 7, 1, 5, or 7 and 1 and 5 and 3. So there's just one race, and it has this huge time number. So let's grab these again, and let's just remove the spaces here. I think this will work. And we should just get an array. Oops. Okay, so if we run this again, all right, 380-17587, 380-17587. Boom. Okay. All right, so that is the answer for part 2. So relatively straightforward. This is fun using zip. Check that out. That is one of the enumerable methods. Let's see if we can clean this up a little bit. We've got like this accumulator thing that's dangling around, and we're printing that out at the end. One way we could improve this is like move our accumulation, like the logic for accumulating all of these up, into a reduce method. And we can start our accumulator at 1, and then we can pass in the accumulator as the first argument to the block. The second argument to the block is going to be the element yielded by the iterator. And because before we were just getting an array, we were able to implicitly destructure. But now we have one argument that is going to be the accumulator, and the second argument is going to be the array of time and record. And so we need to use these parentheses to explicitly deconstruct that into the arguments. So now I think what we can do is just return accumulator times ways, and this should give us back some number, result, and then we'll p result, and then we can remove the accumulator from the top and bottom, and we get the same answer, so that's cool. Now we've got ways here. There's likely some other things we can do. Seconds held times the time minus seconds held. This distance can actually be just replaced inside of here. We don't actually need to go that far. It's worth noting there are solutions to this problem that use a pure math solution. So you can use the quadratic equation. Now, one other thing that we could do is we can actually optimize this quite a bit, right? Like right now, we're counting up the ways. We're iterating over all of the different potential seconds held, but really we only need to go, like the list is going to be something like 0, 6, 10, 12, 12, 6, 0, or something like this. So we have this mountain where we're starting low, we're going high, and then we're going back down. And we're going to have some slice that goes through the mountain. So there's 2 points. If we can find those 2 points, then you just take the difference between those two and you get the count of those that are in the middle. But another way that we could improve this is we could count up, the number of ways that are below the curve. And then we could count up the number of ways that are below the curve on the other side, and then combine those two, subtract them from the total, and get the answer. So there's a few different ways to optimize this, but I think this is the one, in my opinion, that reads the cleanest. And since it works, I'm just going to keep it like this. Thanks so much for watching, and we'll see you in the next one.